This is problem number 8 from section 1.3. It says find the function value, and they give you sine squared equals 5 pi over 12. Now the sine squared should be throwing you off a little bit. Whenever I see sine squared, the first thing I want to think about is using a double angle formula or maybe a sum and difference formula, but you notice they don't have any squares in the functions there. So this is not what I'm thinking about at first, but we may end up having to use that. They give you all sorts of different forms. All I'm really looking for is a form that has just sine squared in it. You can see that I've got one formula, cosine 2 theta equals 1 minus 2 sine squared, as one of the formulas that I can use. I could also use this sine squared formula as 1/2 1 minus cosine 2 theta. Either one of those, there's two different forms there that I could use. I'm going to go ahead and use I think I'm going to go ahead and use this sine squared theta equals 1/2 1 minus cosine 2 theta. I think that's the easiest route to take. So in our case, we'd have sine squared 5 pi over 12 is equal to, and by the way, this formula is just the formula right here rearranged. So I'm going to use sine squared theta 5 pi over 12 equals, this would be 1/2, and this is 1 minus cosine, and this would be inside here I have 2 and then whatever my theta is, which is 5 pi over 12. So I have 5 pi over 12 inside there as well. But I have a third parenthesis there. A lot going on there. All right, I'm going to slide these off to the side just a little bit. Now we got to do some algebra work. So I can say that this equals 1/2, and then in here I have 1 minus, if I take 2 times 5 pi over 12, the 2 and the 12 cancel, leaving me with 5 pi over 6. So I have cosine 5 pi over 6. I can bring out the unit circle and say I can evaluate cosine of 5 pi over 6. As 5 pi over 6, cosine is negative root 3 over 2. So I can say that this is now 1/2 1 minus negative root 3 over 2. So that's actually 1/2 1 plus root 3 over 2. Let's distribute the 1/2 to each term. That's 1/2 plus root 3 over 4. Find a common denominator here, and that'd be 2 over 4 plus root 3 over 4. And when I add those together, I end up with 2 plus root 3 over 4. Now again, I want to recap this because I saw that I had sine squared, and I assumed I was going to have to use one of these formulas here. Now, I looked for a sine squared formula that had just sine squared in it, and then obviously we're converting it to a double angle formula. I looked at the sum and differences. I put them on here because you always want to have these available because they can help you solve specific problems, but they didn't have any squares in them, so we couldn't really use that in this case. So I hope you understand the logic behind coming up with this answer.